Thank you for showing up today. I know the weather is supposed to be a little bit hard out there, so I'm glad so many people showed up. A little bit about myself. I am Sarah Willock. I am a Senior Director of Technology at Loblaw. My pronouns are she and her. I do oversee the technology ecosystem that supports both Loblaw's and Shoppers Drug Mart. This technology oversight includes teams that build and maintain interconnected systems. Usually it's a mixture of technology maturity, so we still have some kind of legacy technology, but obviously fully embracing the cloud as well. My team supports many applications, and we do support the end-to-end experience, so from strategy ideation all the way to support and maintenance once they're actually launched. As a leader, I enjoy not only modernizing, but also supporting rapid team growth. As you take a shift to the cloud, it's so important to make sure that your team structure and your team's skill set supports that shift as well, which we'll talk about quite a lot in here as well. I am a supporter of diversity, equity, and inclusion. As a woman in technology, I am proud to make sure that my team also represents a lot of that diversity as well. I am not an expert in MongoDB. I'm an aspiring expert, but you're gonna get more of a little bit of a leadership view of the technologies that we've chosen, why we chose them, and how we supported the team throughout that journey. But enough about me. I hope everyone does really know what Loblaw is. We all are from Canada, I think. But just in case, we're gonna be walking through just a little bit about what Loblaw is so that everyone understands the company that we're speaking about. We are Canada's largest retailer. We have over 200,000 employees, and we operate in 5 different banners. The first one shown here is pharmacy healthcare. We will be focusing a lot on that today. The second is our discount, including things like Real Canadian Superstore and No Frills. The third banner is our market banners, so like Loblaw, Zehrs, Fortinos, and Independent. We have PC Financial. PC Financial includes our MasterCard, our money account, insurance, and mobile. And the last one is Joe Fresh, so apparel, accessories, footwear, beauty, some of which I have on today, just to do a little bit of a plug for my own company. Today I'm gonna be focusing on pharmacy healthcare. We support pharmacy healthcare services at Shoppers Drug Mart locations and also in many grocery stores. With over 1,300 stores, we are often the top choice for many Canadians to gather medicines, vaccines, services, everything that helps Canadians live life well. Of course, pharmacy healthcare extends beyond what you would normally see in a pharmacy experience. You might not be aware of it. Centralized robotic sites to package large batch medicines, supporting long-term care facilities and homes, retirement communities, prisons, hospitals, all with life-saving solutions and medicines. If you can imagine the ecosystem and the technology behind it, obviously it is immense. We also have online presence, which also you might not be aware of. If you do, you might have a PC Health app. It is an app that allows customers to interact with our pharmacy and healthcare offerings. In addition, we have things like WellWise, Specialty Health Network. These are unique customer needs. I'm not sure if anyone uses them, but we do have a lot of online presence to allow customers to interact with our brand as well. I am part of Loblaw Technology. Unlike many technology companies out there, we were not born in the cloud. We have been around for quite some time, and because of that, we are on a journey towards the cloud. I am happy and proud to say we're about 80% done that journey, which is really great for an enterprise like ourselves. And we are constantly innovating and pushing for our teams to embrace the cloud. In a portfolio such as pharmacy healthcare, it is filled with 50+ applications that we are all trying to get to this journey and path towards the cloud. This is our standard process. Really, we start with planning, making sure we cataloged all the features, making sure that we understand commonalities, rationalizing which apps, so using AppRat to assign ratings of each application, ease of benefit of moving to the cloud, and obviously security. Based off that rating, we determine how to start strangling some of those features. Those separate features could be then hosted on the cloud, and then we have to pay special close attention to security and documentation as we live in that hybrid world. Obviously, in an enterprise like Loblaw, you can't migrate everything at once. You will be in that hybrid world for quite some time. We determine the level of modernization. We all know the words, so re-platform, re-host, re-engineer, re-architect, to figure out how far to take every application as we move it to the cloud. While we're designing and building, working towards as much tech consolidation as possible, decommissioning techs, apps, and environments that are no longer needed, establishing monitoring and operation structure, shifting to DevOps so that the teams have autonomy of change, And the last one is making sure that we're optimized to grow. So remove barriers, allowing dev teams to have visibility into cost, and making sure that we incentivize improvement. I will be focusing the remainder of this time speaking on one specific application, an application that we took and made sure that we, from the ground up, revolutionized and modernized, and is a key technology that we actually have in our services right now. We identified an opportunity. Can anyone see the opportunity? If anyone can't, the opportunity is that this is far too complex. This truly is one of the systems that we were kind of handed, and if anyone has worked in IT for quite some time, you probably have either built or maintained a system that looked like this. I encourage you, don't try to read it. It's not really the point. This is just really trying to showcase the size of the application that we were having to tackle.
System A looks kind of important.
System A is the most important, absolutely. Yeah, obviously a name that we plugged over top of it. So we had this application, and it grew and became bloated. Even worse, there were many systems, as you can see, relying on this large monolith. It was a 10-year plus system that was built 10 plus years ago, and it was beginning to show its age. Portions of this application were hosted on data centers, portions of them were distributed to local servers. This reliance on physical hardware was problematic and obviously very costly. 10 years ago, what's not shown in that diagram is there's one giant SQL database in that system A. That probably sounded really good 10 years ago when the system was small, but obviously as the years have progressed, that is beginning to have problems. You can only partition, shard, and index so many times until you realize that is the wrong technology choice for that system over time. In addition, the data storage was holding us back. Our customers are used to us engaging with them, providing incremental value, and kind of marketing to them. This database wasn't really allowing that because it was so bloated, and we were trying to make sure all system performance was focused on just keeping the system stable, that we weren't actually augmenting with a lot of the other features that we really wanted to and that customers are used to us providing. Trying to flip to the next slide. Good. So I think we can all agree this looks much better. This was our conceptualized architecture. Obviously, this is not representing of what we finally built, but we worked together to determine the desired architecture. And like any desired architecture, you should have goals. Our goals at the very beginning was cloud-hosted, native-focused. That was our number one goal throughout this entire process. We optimized to ensure maintainability and reliance targets were achieved. We removed dependency on local servers and data centers, but not by lifting and shifting. This was a complete greenfield development and modernization effort that we had underway. We did take a domain-driven approach, which you will hear about a few times in my content, and we leveraged a modular and microservices-based architecture. This allowed us to be agile in our engineering and add complexity only when needed. We were able to obfuscate the other domains' complexity from the domains that really didn't need that context. And in the end, we built a lightweight application. We did improve our data storage. We picked the right technology for the project based off the requirements that we had now, but also future needs. In 10 years, pharmacy healthcare will look different. Even if you think back 3 years ago, pharmacy healthcare looked different. So we made sure that we were choosing a scalable technology and a scalable architecture that would allow us to grow with those changing needs of that business. There's a lot of conversation, obviously, around this topic. Lastly, we picked a technology that would support our scaling requirements. The system has very high traffic, and the requirements have really long-term storage requirements. Because of legal legislation, we have requirements to store data quite some time after a person turns legal age. So if you've gotten a baby medicine, we have to store that medicine until they turn legal age, and then we need to store those records for about 18 years beyond that. So we have usually on average about 30, 35 years plus of legal requirements to store data. So as you can imagine, that's a lot of data for someone that prescribes as much medicines as we do in Canada. So now that we knew what we wanted to build, we needed to pick the right technology. That persistence layer was going to be key for us because we knew that was one of the big drivers of the old architecture that was holding us back. The optimal database solution for a system varies based off requirements. Availability, consistency, tolerance, scalability, all these lovely words. We needed to make sure we maintained that. But by selecting the best database technology for our specific problem, we can break away from the monolith database and that is obviously restrictive, and then move to focusing on meeting our business needs. We, of course, started with collecting business requirements. Our requirements list, we prioritized and collected and kind of evaluated. I wish this screen depicted all the requirements we had. Obviously, this was just a small subsection. It was an exhaustive list if you think of the requirements we have on a system this large. A few to call attention to, just because they're unique to my industry. In pharmacy healthcare, we are always dealing with PHI and PII data. Pretty much everything in our system is confidential and needs to be treated very securely. So data security, data governance, and all the kind of the world around that is top importance. In this industry, we also integrate and store data considering FHIR standards. So HL7, HL7 V2, V3, FHIR, all of that. We are making sure that we have a persistence layer that can easily adapt to that standard and not have to do too much transformation in and out of our system. Our application is also dealing with a very large amount of data. Not only how long we need to store the data, but literally when you think of you going into a pharmacy and picking up prescriptions and getting medicine, there is a lot of metadata that goes along with the data that you're actually capturing in that system. Because of the volume, high throughput, high availability, and sharding, absolute necessities, wouldn't have chosen a technology that really couldn't have supported that. The ability to stream data to other places is also important. Realistically, our system, as much as it's super powerful, needs to be empowered by other systems within Loblaw, analytical systems, audit systems, so making sure that we are able to stream data out of our system into other connected ecosystems, top of mind. The last one is just to make sure we are known for really good systems. We are known to make sure that customers can come in, get the services and medicine they need, and leave. So we needed to make sure that our system was going to be performant and always available to meet the needs of our customers. So what you see on the screen right here is a comparison. I know you know this. The reason why we put this up here is just to make sure we understand every single thing, every decision we make, at least in Loblaws, and I encourage in most companies, you really catalog and mark those decisions as artifacts in your project. This is a good example. In our company, most of my engineers on my team were used to SQL. Let's be honest, it's been around for quite some time. In an enterprise like ours, SQL is usually pretty widely used. But we didn't want that to sway our process and make sure that we are not using that as the single point of reference when choosing a new technology. Sorry. On this slide, the blue represents obviously good. I also just want to preface this with, this is in our situation, in our project. Obviously, everyone is a different case, so this shouldn't be taken completely point blank. In the end, when we went through all the requirements, we did determine NoSQL was simple, efficient, and much easier to achieve the business requirements that we just talked about on the last slide. It would help us expedite our engineers and improve maintenance, including making changes post-build. Once we made that decision, obviously that sparked a pattern of decisions that we needed to make. Go further in choosing that technology. And as soon as we decided to go the NoSQL route, you'll also see content in here about how to support the engineering experience and bring people from a SQL mindset to a NoSQL mindset so that the teams can actually be supported as well. On this slide, you can see kind of a comparison. I want to just make sure that I say it out loud. All three technologies are actually used at Loblaw. All three technologies are great. In this one situation for our application, when we did the comparison, it was really easy to see that MongoDB simply just clicked all the boxes for us for this application. Please note once again, when you're doing this kind of comparison, it's so important to bring in that large audience in your company. Make sure that you're not making that technical decision in isolation of your team, but anyone that might need to use this in the future. If you think of a 10+ year system that was on a SQL database, the amount of people that relied on that system that should know that this decision is being made is pretty vast. So making sure, once again, we artifact, catalog those decisions, and communicate as frequently as possible. If the data is unstructured, consider an object store or a NoSQL store. Our microservices are obviously usually exchanging JSON payloads, which are documents, and using relational database usually implies the usage of an object relational mapping. Within a NoSQL data model, we would normalize these into a single document or a collection, be able to retrieve them obviously in one single request, rather than joining across different documents or tables. This is greatly speeding up our ability to actually engineer and do our query execution. With domain-driven design, which is the application, the architecture pattern that we used in our application, breaking up that monolithic database is 100% considered the norm. And really, when choosing this technology, we were able to embrace the eventuality of consistency, and that ACID transaction is a little less prominent and needed when we're having some of that consistency across our domains. Lastly, once we decided that we were going to use MongoDB, because it clicked all those boxes, we had to discuss hosting options. We had two options available to us, MongoDB Atlas and MongoDB kind of self-hosted or Loblaw hosted. When we went through this, it was also really important to look at the teams that would support it. MongoDB Atlas, obviously, cloud-based managing database, is going to allow us to have a monthly subscription, but unpack a lot of those enterprise features. It is best for scaling workloads, optimizing performance, and lowering the total cost of ownership. We wouldn't have to manage the underlying infrastructure. We could be leveraging Atlas's fully backup and recovery solutions, snapshots on demand. The monitoring alerts obviously come out of the box with MongoDB Atlas. They're very easy to configure and easy to implement the vertical and horizontal scaling that we needed. Lastly, the SLO that we were able to achieve on Atlas, 99.995, which is absolutely amazing and achieved the high availability that we were expecting and needing on our application. Comparing this to hosting ourselves, and I will be clear, on Loblaw, we actually are very used to hosting our own technologies. So this was a big debate internally at Loblaw. Self-hosting comes with a higher licensing fee, and of course, it also comes with a lot of other additional costs. We would need to scale up the team to make sure they can support underlying infrastructure, support the replication. We would need to configure and manage backups, recovery, monitors, alerts. Scaling is possible, but once again, it has to be configured. And then the uptime SLO was actually something that we really heavily calculated. Once again, every company should do this themselves, but when we were planning to host this on GCP, we calculated an SLO on the self-hosted as 99.95, which falls a little bit short of what we wanted as our high availability for our application. I think everyone could probably guess which one we chose. We chose MongoDB Atlas, so hosted on Atlas. It is important, once again, when you go through this discussion, make sure you include stakeholders, connect the teams that would be using and are impacted these decisions. If you have SRE or infrastructure teams, make sure they're included. And make sure that, once again, these artifacts are stored. Because very similar to the first application, 10 years ago, they probably made the right decision to use SQL database, but that obviously changed over time. And 10 years from now, I don't want anyone to question why we chose our technology. I want them to be able to look back at these artifacts and understand exactly the decisioning that went around those choices. MongoDB Atlas provided high availability, high performance, and we needed them for our system. The SLO provided helps us maintain our overall application SLO that we were looking for. It does also have low RTO and RPO with cross-region replicas, so that ensures our application is hitting a high availability, but also if something ever happened, we would have the ability to recover quickly. With built-in tools like Performance Advisor and Query Profiler, it allowed us to fine-tune our data structures and make sure our engineers feel supported in the development process. Scaling was a must. With horizontal scaling, we were able to add more shards and replicas with zero impact to our application services. In addition, vertical scaling as the application breathes was also possible. It does support up to 4 terabytes per shard. It can be extended up to 200. I want to be very clear, we don't need 200, but it's always great to know that there's that flexibility. If you ever need to scale up, we have the ability to get larger than we even are forecasting in our plans right now. A very important factor for us, it was also the support, making sure that we felt supported with a partner. My team, my engineering team, was heavily based off SQL. You'll see a lot of content about training and providing that support, but 100% important for us to make sure that we had the support from that partner. And lastly, security. I will be honest, it's very easy to get internal security approvals when a technology either meets or extends beyond industry standards. Between access controls, the VPC peering, all the required encryptions that were there, we really had no concerns brought from security on the actual database technology, which is a huge win in an enterprise. So now we picked MongoDB. We picked hosting on Atlas. We felt really prepared. So now what? Obviously, we needed to really set our expectations and set the experience for the engineering team, which is our next focus. It is so important when picking a right technology to make sure that if you don't adequately support your team, the technology will fail. We shouldn't be taking architects and engineers that worked on SQL databases for the last 10 years and just expecting them to know how to design, execute, and operate non-SQL stores. So what we did is we made sure that we gave them ability to try out and give them a playground. That playground allowed the teams to work safely, try out models, patterns, integrations without the fear of interfering with the application, the environments, and the test data. They were able to take the learnings from that training and actually execute them and share them with colleagues. In this world, we did plan for additional time in our project to allow for some of that playground activity. We wanted the teams to feel that they could take their own time, learn what they needed to, and share that back with the teams. MongoDB Atlas team has supported both architecture and delivery teams throughout the implementation. They were obviously reachable, detail-oriented, and obviously offered really good recommendations. I'm going to be walking through some of the training that we received just to make sure we all understand the commitment that we made to learning, which I really do think made us successful in the end. One of them, basics in development training. We put that across the board. We made sure everyone on the application team went through those basics in development training. Even if you're not an engineer, if you're a DevOps, if you are a QA, even if you're a product person, to understand how your data is stored is obviously very important. So everyone went through the fundamental training. We had a huge reliance on Atlas search. So there's specific Atlas search and support training that we also put the engineers through to make sure they really knew how to reap the benefits and the features that Atlas search had. High availability, SLA, disaster recovery, architecture patterns. We have many architects on this team, and we wanted to make sure that they knew that they were designing for a different type of technology, and we gave them the training to do that. Indexing guidelines. With the large amount of data, we wanted everyone to understand exactly when and how to index as well, so we went through the MongoDB indexing guidelines and made sure the teams always had that readily available. Data modeling guidelines we also went through with the teams, and restore and backup guidelines. The last one is we extended the MongoDB University training to the entire team, making sure that anyone that wanted to have that university training, we gave them not only obviously access, but the time to take that university training to make sure that they're once again equipped to take on the challenges that we had in our backlogs. We have been working with MongoDB to closely validate the work that is underway and follow recommended standards. We also have made sure that they're involved near the end where we're doing performance tuning and some recommendations for efficiency changes. The people aspect of technology can be a large barrier for growing an effective team. And while we did have some bumps, we had some bumps around business objects and clustering strategies, we were able to quickly resolve. And because of MongoDB being a partner with us and all the training, even more important, we resolved them within the team. We were able to do some fast learning, some fast discussions, and be able to figure out exactly how to resolve the issues we had. We did have to do a little bit of retrofitting on reorganization of how our data was associated with sites, and we rebuilt some clusters to make sure that we were aligned with the success metrics of the application. The whole process from beginning to end, we maintained this kind of constant learning throughout, and we made sure that MongoDB was really used for consultancy when we just needed to validate something. Something didn't feel right. We brought MongoDB in just to validate that we were on the right path. So I'm taking a little bit of a shift. I want to start talking about some of the experience for the different roles on the team. When we started, obviously we started with a little bit of an architecture lens first. We have many architects working on the various domains, and we wanted to make sure, because some domains have different needs than others, the advanced implementation of patterns allowed for effective changes across domains. Attribute pattern absolutely was used for collections with high computations and resource loads. Polymorphic pattern was used when we really needed to search fast. There is definitely a trade-off for reading, but sometimes it's just needed for a faster search. And then document versioning pattern definitely was needed as well to keep track of our audits and make sure our structural change data set was captured so that we could stream that to other systems as needed. It also offered a lot of flexibility in our actual data schema. Nesting dimensional data into fact collections helped us optimize our data fetches and improve our cost maturity. Obviously, less fetches makes cleaner code as well. Then taking a look at engineers. Now that we have happy architects, we're shifting our focus to engineers. We have many engineers that worked across this, and really what we saw is MongoDB made it easier for them to implement and made our engineering teams faster. We measure velocity as every individual domain team, and we actually tracked velocity increases because they were no longer bogged down by the configuration of data technology and some of that reduction of toil. Embedded data aggregation made our applications quicker themselves, and we had cleaner code because we didn't have to fetch so many fragmented data sources and kind of augment those inside the system. Data sharding, we've talked a lot about it. We needed it in our application. And what was so great is if you talk to my team, they barely would say this is a requirement. And the reason why is it actually didn't require a lot of effort for us to assign and kind of configure this. Our engineers didn't need to know how to data shard. They needed to be able to configure it and then moved on with other business tasks. So this was a huge win for us. And then MongoDB search. It helped with fuzzy search and incorporated language independence. It helped us implementing free search, both full and partial, and irrespective of the column details that we were being searched upon. An important thing to call out here is my team mostly had Elasticsearch experience going in, and we did a little bit of comparison. Obviously, this is not an official comparison, but the team has really kind of announced that it is a lot easier to use the MongoDB search, and realistically, it was a lot faster from not only a development standpoint, but the results that they got back. What does that leave me with? Happy engineers. Going to connected to the enterprise, obviously this application without being connected means nothing. So we also focused on all of the interconnected systems. Unified data was one of the biggest things that we focused on for those systems. Integration teams, making sure that we were removing misinterpretation. Once we actually had our Java models matching our API, matching our JSON, having that consistency of data understanding and data context throughout the entire application removes the need to have that tribal knowledge. Realistically, when a system is connecting with us, it's very easy to identify the data, it's clearly marked, and if anyone has questions about that data, you can track that data lineage all the way through the application very easily without having to, once again, look at documents or talk to the engineer that's been here 10 years and trying to trace that down. CDC support, we streamlined, pun intended, how we connected to systems. We do use CDC data capture to propel a lot of our interconnected systems, like our data lakes and our audit and traceability. And really, we didn't have to focus a lot of time, once again, on how to configure this. We were able to really emit data and make sure that that data is moving across very seamlessly through MongoDB, and we can focus a lot more on some of our business problems. Rather than increasing dependencies and responsibilities upstream, the microservices could give a single responsibility, creating clear separation of concerns between workflow and change audit data. What does that leave me with? Happy operations and happy partners. So obviously my other teams within Loblaws would be considered my partners or external systems. When they obviously come to us and they say, oh, you have to integrate with another system, when we realized actually how easy it was to integrate with these data sources, they complained a lot less, which is always important. And the last one to kind of mention is data migration. I think we still have some learnings on this one, but I wanted to at least showcase what we've learned so far. When launching this application, we did have to do a data migration from old to new. Normally, that's a huge concern from an enterprise level, because when you're moving that level of data, just making sure all the data is successfully moved is obviously a little bit hard. MongoDB fast, secureable write performance allows us to use the same APIs that we were using in the application to support our data migration. A traditional approach would have been you migrate all your data in kind of batch inserts, and then you use your API once you go to production. This was allowing us to use the APIs for data migration, allowed us to make sure that we were kind of testing a lot of our APIs ahead of time. It also allowed us to improve coherency and reduce any mistakes of custom migration flows, which is always a concern. What does that leave me with? Something I've never been able to say, happy data custodians, because they had less concern about our data moving from one system to the other system. We kind of ensured that the coherency of data was always going to be there. I'm going to finish off with just my last learnings. Just a summary from kind of beginning to end. When we're choosing that technology, make sure that you're including the business partners and stakeholders in those decisions. Make sure you communicate the decision and why you're making that decision. Support the new team with either playgrounds or just verify play to make sure those teams are encouraged to use the new technology to its full potential. From a development standpoint, one of my biggest learnings, avoid noisy neighbors. Domain-heavy data queries should be, and mutations should be segregated into their own clusters. Take advantage of VPC peering. Obviously, it's there for a reason, and it's allowing us to make sure that one project is all within the same peering network. And then ensuring monitor and alerts are also in place when you go to production. So happy with the partnership with MongoDB and Loblaw. We've come a long way, and I think there's a lot of projects that we're going to be able to support in the future. One more. I would be remiss if I didn't have to say this. It is a great company to work with. We are always hiring. Make sure that you check out our websites for careers if you are interested, of course. Just announced last month, for 14th year in a row, we are recognized as Canadians' top employer. So check out our website for careers or talk to me if you wish. But thank you, everyone.